Let's go through one more example of graphing a rational function. This one is going to have some additional characteristics we want to look at. But we'll take the same approach as we did on the first problem and take it one piece at a time. So with this right here, it looks like I can factor something out of the top. I don't know if that's going to help me, but we'll at least write it down in simplified form. That might help as we go along. So first thing, vertical asymptote. Vertical asymptotes are when the denominator goes to 0 and the factor does not cancel out. And we can see right here this x plus 1 factor does not cancel out. So that means x cannot equal a negative 1. So that means my vertical asymptote is going to be at x equals negative 1. That's what makes that denominator go to 0. Second thing is horizontal asymptote. Remember, there's 3 criteria for horizontal asymptote. If the degree of the denominator is larger than the numerator, it's y equals 0. If the degrees are the same, it's the ratio of the coefficients in front of the largest terms, which in this case would be the same degrees. Or we have no horizontal asymptote if the degree of the numerator is larger than the degree of the denominator. And that's the case we see right here, a degree of 2 versus a degree of 1. So we're not going to have any horizontal asymptote. A slant asymptote occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. And that's the situation that we have right here. An x squared over an x, a degree of 2 over a degree of 1. So this one is going to have a slant asymptote. The way we find the slant asymptote is we divide our function using long division. So x squared minus x divided by x plus 1. So what times x gives me an x squared? We have x, which is going to give me an x squared minus an x. Then you subtract and you switch both signs. Sorry, this one should be negative right there. It should have been plus originally. So we get negative 2x plus 0. Then what times x gives me a negative 2x? It's negative 2. So negative 2x minus 2. When you subtract, you switch the signs of both, and I'm left with a remainder of a positive 2. Now your slant asymptote is the piece without the remainder. So there's my slant asymptote, x minus 2. So my slant asymptote is going to be y equals x minus 2. The fourth characteristic here, holes. Holes occur when the factors do cancel out. We've got no factors that cancel out, so on the holes we're going to say none. If we look at our intercepts, we've got our x-intercepts we want to look at and our y-intercepts. The x-intercept is when we set y equal to 0, and our y-intercept is when we set x equal to 0. So our y-intercept is going to be 0 comma something. So for my y-intercept, we are going to plug in a 0 wherever we have an x. So we're going to have 0 squared minus 0 over 0 plus 1, which is going to be just 0. So my y-intercept is going to be 0, 0. The x-intercepts occur when we set the y piece equal to 0. So I'm going to take that same equation, x squared minus x over x plus 1, and now I'm going to set y equal to 0. And if I solve that out, cross multiply here, this x plus 1 times 0 just is 0. So I get 0 equals x squared minus x. Factor out the x. And if I solve this, I get x is equal to 0 for the first piece, and then x is equal to 1 for the piece inside the parentheses. So my x-intercepts are always in the format, are always in the format of something comma 0. So my x-intercepts are right there. And I have x equals 0 and x is equaling 1. So there's my two intercepts. And the origin right there, 0, 0, that crosses both the x and the y axis, so it makes sense that I can define those as either intercepts. Finally, the domain. We want to exclude our x values that the equation cannot be, which will be that x equals -1. So go from negative infinity to -1, union with -1 to infinity. So now I've got all those pieces, we can begin to graph this out. The first piece, we have a vertical asymptote at x equal to -1. So we'll go to -1, and we've got vertical asymptote as x equals -1. No horizontal asymptote. We do have a slant asymptote, which is x minus 2. So if we have the line x minus 2, that's a y-intercept at -2 and a slope of 1. So our slant asymptote is going to be just a straight line, slant asymptote, y equals x minus 2. We've got our intercepts at 0, 0, and then 1, 0. So I know right there's 0, 0, and there's 1, 0. And I know that my graph is going to hug these asymptotes. So on my right-hand side here, I'm going to come down and I've got to go through my intercepts. So that first part is going to be right there. The second question then is, where is it going to be on the left-hand side? Is it going to be above or below? And we actually know that answer without doing any further math because we know we've got no x-intercepts over here. So the graph has to go down here. Now, if you didn't pick up on the fact that you don't have any x-intercepts over there, and you're like, okay, is it going to be above that asymptote or is it going to be beneath it? You can always plug into your equation. So let's say we said let x equal a -2. Well, let's choose something further over than -1. And if we let x equal -2, we plug in -2 here, -2 quantity squared minus a -2 over -2 plus 1. We get y is going to be a -6. So at -2, I'm going to be way down here at -6. So that just confirms that my graph is going to be down there. Once you've done all that, you want to do a quick confirmation on your calculator. X squared minus x divided by x plus 1 and hit graph. And sure enough, you can see a quick sketch there of what the graph looks like. Goes through 0, 0, and then 1, 0 up there. And then down here you can see the graph stays beneath the slant asymptote. We'd have a vertical asymptote right there. Slant asymptote goes diagonally right there.